Hello friends of .NET, I'm Emil Landworth and you can find me on Twitter at TerraJobst. I'm super excited about this episode. I'm not saying this because it's the usual phrase that everybody seems to use these days. It's because I'm actually quite excited. I've done a lot of rewrites before I went live on this episode, so I tried out various things and I'm actually quite happy with what I think the direction should be for us today. So I'll still be coding live, so you can still see me struggle through the various aspects of the things, but usually my episodes are prepared so I know where I want to take you in the next 2 hours. And you never know how fast you can go, but we will find out what's going on and whether we can succeed. So the prime purpose of today is to add statements. And not just statements, but also variable declarations with proper scoping. Because so far we have done this somewhat ghetto-style variable declaration where the first assignment is creating the variable, and that didn't work super well. There's a few bugs that we will look at as well. And it also doesn't follow normal scoping rules, which we also have to add when we have block statements and other things. You want to make sure that variables are found correctly and things actually make sense. So I have a quick demo prepared for you. So there's also some coloring I want to do because, quite frankly, I care about colors, and I think the console experience benefits from being a bit more on the colorful side of the house. And we will also improve our scripting abilities because when you're running in a REPL, it is quite common that you want to be able to redeclare variables, meaning you create a brand new one with the same name but with a different type, and you want things to work properly in this case as well. All right, then let's just jump right in. So first, before we go anywhere else, let's first check out where our GitHub repo is. I've received a pull request again, which I'm always very happy when this happens, especially things like this. I'm probably butchering his name, but I think his name is Thais, I think. And he noticed that I have this here. And I have honestly no idea how this happened. I suppose there was an autocomplete or an extract refactoring thing that added it, because I really can't see myself typing this dot ever in my source code because I'm really not a fan of this. So this is a very easy change for me to accept. So let's do this right now. Booyah. And then there are issues. So this is super awesome. So let's just open them all. So Dimitri, I think if it's pronounced, filed a few issues where he noticed that when we have invalid input, that we are crashing. And I looked into this a little bit. It's actually somewhat straightforward why we are crashing. So let's find out what's going on the debugger before we go anything further than that, because it's always good to start with a clean working copy. Let me just quickly find out what I want to do right now. I want to say .NET run so we can actually reproduce the error. All right. Clearly my machine was somewhat asleep. Seems like it also needs some coffee. So in his case, he just has a dot as an input. And yes, we are crashing in source text toString here. So let's actually find out what's going on. Let's launch a real debugger. Probably should have done this earlier anyway. Da, 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 da. Anything happening here? I guess not yet. Is it initializing? Oh, there you go. Sorry. I was sitting at 5 like a maniac and nothing happened. Patience, my young Padawan, patience. All right, so if we hit dot, oh yeah, now I have a million instances because of this is the pain of impatient people. You end up with too many instances of your problem. Booyah! And now we are crashing. So what's happening here? So we get a start of 5 and the length of -2. That's somewhat curious. How did we end up here? So the suffix span has a length of -2. How does this happen? Well, we're saying go from the diagnostic span end to the line end. Yeah, going from 5 to 3 is not working very well, is it? So let's look at what our text actually looks like. So we have our source text here, which is effectively dot followed by 2 line breaks, carriage return line feed. So there's \r\n, so that's carriage return line feed twice. And it's claiming it has 2 lines. But that's not really correct, is it? Because if you think about it, you have a dot followed by 1 line break. And then you have followed by another line break. So basically this one is the dot, carriage return line feed. This one is carriage return line feed. So technically speaking, you have 3 lines where the third line is empty and the third line does not have a carriage return line feed. So what ends up happening here is when we ask for the diagnostic span, the diagnostic span ends at position 5. And so when we go into our binary search we did the last time and we say, okay, give me the line number for position 5, we end up returning line number 2. But line number 2, if you look into it, only goes from 3 to 3, right? So the additional line break character that was there is basically nowhere to be found because it's basically logically belonging, positioning to the next line. So long story short, what the problem here is that when we go to our, oh God, how many debuggers did I end up launching? It's a good morning. So if we go to source text, so this is the part where we do our binary search here. And so what ends up, sorry, our binary search, this is where we basically say, okay, go over the source text and then go over the characters, and then for each character figure out whether it's a line break, and if it is a line break, if it's not a line break, just advance, but if it is a line break, add the line. And so at the very bottom here we are saying if you still have characters left, then add the line. And as it always is with source code, the fix is a 1 character change. It's basically if position is larger than line start, that means the line was not empty, so we add it. But also if you're at the beginning of an empty line, it's also a new line, so we should add it. So let me run this again. And so he had 2 repros. He had one here with the dot. He had one with the Halloween, which was funny because he actually filed it, I think, on actually Halloween. So if we now do this, it doesn't crash anymore. And if I'm entering a Halloween character, one of them is enough, I think. Well, this is where you can see Unicode in action. So this is a multi-byte character. So so basically we see it as 2 question marks because we don't actually support, pumpkins, I guess, in our input file. So we say this character is illegal and the next one is also legal. But we don't crash, so that's good. The second repro he had was very similar. So if we do this, basically the story here is there's a bunch of open parentheses, and so there's a missing close parenthesis. So if I now go there, it's the same symptom, right? It's always the problem of when I report an error at end of file token is when the thing used to crash, because that's when we basically miss our last line. So bad things are no longer happening. We get proper error reporting and, well, as proper as it gets, right? At least we don't crash. We still have too many cascading issues, I would argue. Let me actually pull down the commit I just merged, the PR I just merged, and now let's just stage what we currently did, which is just this one line change here. And so we say git commit m. make sure that the last line is added to source text. We currently only add the last line if it's empty, but we also need to add empty last lines. This fixes, which one does it fix? It fixes 12 and it fixes 13. This fixes number 12 and fixes number 13. I'm not sure I have to say fixes again here, but the thing is when I do this thing here, when I say fixes 12 and I push the commit to GitHub, it will automatically close the issues. I believe you have to prefix the number with fixes directly. I think if I do this, I don't think 13 gets closed. I might be wrong, but just to be on the safe side here. And yes, I probably should have created a PR for this, but hey. And see, this one is closed. All right, so now let's ignore these two. And let's look at these guys here. So that's a more interesting one. So basically, let's run this in the debugger again. And it's a equals 1 plus b. A equals 1 plus b. All right, we get an error for this, as you would expect. And then we say b equals a plus 1. B equals a plus 1. And so what ends up happening now is we try to evaluate the last expression, but because this expression here, when we evaluated this, it had diagnostics, so we didn't actually add the variable a into the scope. And so now when we're evaluating this, we basically find the variable, we're actually successfully binding it, but when we try to get a value for this variable, one of them is null, and if you try to cast null to an int, we get a null reference exception because, you know, there's nothing there to be casted from. And so that is an example of where our current scoping mechanism, where we just initialize variables on first use, is actually, I mean, we can probably fix that, but I don't want to fix that bug. I want to just replace the whole scoping mechanism with something else. And then the problem will disappear. So let's ignore this one here, and I think this one is more or less the same thing. It's not a null reference, but it's kind of the same kind of issue where when we evaluate this guy here, we basically have a similar issue with scoping where we basically evaluate this expression first, which means we initialize a to 1, and then we later on are able to assign it. So we basically say, okay, now it's 10 plus 1, and then we assign this to a, so it's 11. But then we actually try to add it later, then there is some issue with our dictionary handling, and then again, we don't find the key in the thing. But again, like both bugs will be fixed by just us doing variables the way it was intended to be done. So I think at this point I'm ready to create a new branch, episode 6 statements. And now let's get going. I should be live, right? That is very funny. So apparently I'm not live on YouTube, which is which is a problem I did not have before. So let's quickly check out what's going on here. Huh. What is happening? So I am live on Twitch and Mixer apparently, and yeah, for some reason that I don't quite get a handle on, it does not seem that YouTube has it, which is really weird. I never had this problem before. It's always a first, always a first. Well, how about this? We just start recording, just in case I have a backup recording when things go south, because my usual way to do the recording is to just leverage YouTube for this. Let me just quickly see what's happening. So Twitch seems to work. Yep. All right, so with that out of the way, always fun. Anyway, so it seems like we need some more coffee for our friends at YouTube. All right, so now we have the branch. Let me find my notes, because notes are always good. Oh yeah, ha 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 ha. I fixed the bug. And what did I not do? Huh? YouTube? Oh, not YouTube. Streaming community. Did you pay attention? What did I not do? I did not add a test. That's what I did. Or that's what I didn't do. So let's do this first, because those kind of tests are extremely annoying. So let's add a new type here. Let's call this source text tests, and we say public void source text includes last line, and then we say string text int number expected line count, something like this. And then we say this is a theory, and then we say this is inline data, and then we start with our simple case where we just have a dot and nothing else, in which case we expect one line. We add, in which case we would expect 2, in which case we would expect 3. Source text is source text from, I guess it doesn't belong in syntax, does it? Let's add a new folder called text. Let's move this guy to its own type. And then we can, nope, not here. We move the source text tests into text. Yep, move that guy. And then we change this one to text. Yeah, what is it? Source text from text, and then we say assert equal expected line count source text lines. What is it, length? Yeah. So let's see what ends up happening. Da, 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 da. All right, we passed all the tests, which is good. So let's see what ends up happening here. Yeah, we added a new file. Big deal. And then let's say add test coverage for bugs 12 and for bug 12, 13. Just to be on the safe side, and then let's actually push this guy. And then let's create our PR for this. Episode 6. Alrighty, so this will get us going. Perfect, so first stuff done. Alright, now I'm 23 minutes in, and the only last thing I want to do here is, because it annoys me a little bit, is that our REPL is so not pretty. So the first thing I want to do is I want to print the actual prompt sign here in a different color. So let's just say foreground color equals console color green. And then here we say reset color. And then I don't like these symbols here, so let's just pull up, oops, the character map. It is a funny Windows bug. Like, the start menu pops up, but for some reason it's behind my taskbar. Super helpful. Anyway, so what did I want to do? I wanted to say character map. Yes, character map. All right, so what we want is, I think, something like more like this, because it looks slightly prettier. I mean, not by much, but. And then maybe instead of having the ugly downpipe, let's have a middle dot. Yeah, this guy here. Yeah. I mean, it is totally better. Now we have, oh my God, look at this, it's beautiful. 12 times 12, and then we say 42, and if I say 12 times 2, let's say 24. Perfect. Now this looks amazingly sexy. Now the only other thing I want to do, I think I want to print the result also in a different color. So where we print the result, that would be here. So let's do this as well. Let's try this and make this. What color did I try that worked really well? I think pink. I think it was pink. Was it pink? Purple? Purple. Oh, it was magenta. Yeah. Here we go. Look at this. Oh my God. It's almost like somebody designed this. And now, instead of doing this here, so the problem is we refactored our write to out, so it's a bit harder to change the colors here. But we can cheat, right? So is to console, we say, is the text writer the same as console.out? Then we are basically saying, great, now we set some colors. So we say, so here's the indentation, here's where we print this, so we say, is actually the marker. Actually, I don't want the marker to be. Yeah, I guess I want the marker to be gray. So let's say is console. Then we write the marker and we say console foreground. Color is console colors dark gray. We say color just for good measure, and then we repeat the same thing here for the token kind, and we say, well, yeah, so we say basically we want to have different colors for the nodes. So say node is syntax token, let's say. Then we say console color, what did I say, blue, I think. Otherwise I say console color cyan. And then we say same thing is to console. And then we reset this here. Something like this. So let's see whether this works. Because it makes things a little bit easier on the console. So if we say show tree, and then I say 12 times 12. Yeah, now it's actually somewhat readable. And I think that's a much nicer experience. Because we will look at these trees a lot more. And, might as well just make them a little bit prettier to look at. Yeah. Add colorization to REPL. All right. Sometimes you have to do what you have to do. All right, now it is time to change our compiler project a little bit. No, somebody's asking what if it is in console. No, right? Did we mess that up? No, I think, no, not this guy. Syntax node, I think. Good point. Good point. Good point. Good point. Yeah. Thinking about it, we can probably reset these guys here. Yeah, I think that's better, right? Does it still work? Should. Yes. So yeah, if we're not attached to the console, we still want to write out, so we don't want to have the whole write under the if. So the only thing we now have here is the foreground color that we change. Yep. Good catch. Good catch. Greg is paying attention. Greg deserves more coffee. So here we go. Git commit. Never happened, right? Never happened. All right, so one thing we want to do now, if we look at how we parse currently, what's a bit annoying is that when we parse, we basically parse the entire syntax tree here. So we return the syntax tree, and then the syntax tree itself has an expression syntax root. The problem with that approach is that if you want to extend this to something that is multiple things, like multiple declarations or multiple statements, then we don't have a singular root object, right? We now have just an array of things. And that makes it really ugly to pass it around, because you have to pass around the whole syntax tree. But the syntax tree itself isn't a node. I mean, we could make it extend node, but that would be super weird. So instead, what many do is they just have this thing that represents the entirety of the input as the root node. And there's different names for this, but a name that seems to stick with most things is the term compilation unit. Strictly speaking, this is not our compilation unit. This comes from C++, where every source file is effectively compiled to its own OBJ file. But it's basically another way to say it's the entire file. And so what this guy basically has is, now we have a syntax node, and that syntax node represents the root of our syntax. So if this guy is an array, then that's fine because I can just pass it on to compilation unit syntax. So let's do this, and we take, in our case, it's an expression syntax root, and then let's call this expression. So and then we have our syntax token end of file token. And so we just initialize those guys, and then why is that squiggled? Oh, because we don't implement everything yet. Yes. So we say this is syntax kind compilation unit. Let's add this to its own new section. Oops. So there will be a few nodes that are neither expressions nor statements. So we just shuffle them there. Move this guy to a separate file. And then what we want to do is we want to say on the syntax tree, instead of taking an expression and this enter file token, we just take the compilation unit. Compilation unit. Already call this root. This guy is gone. And then the other thing we're doing is, instead of doing this, where we allow the syntax tree to be constructed, we make the constructor private. And we don't take these guys, actually. Instead, we're doing what we do here is we do this in here. And the reason we're doing this in here, var root equals parse compilation unit. And then we say diagnostics. We can actually make our lives. Yeah, it doesn't matter. Diagnostics equals parser diagnostics to immutable, right? Because once we have that, we can actually later on also pass in the syntax tree as the parent for everything else, which is a little bit more convenient. So now let's actually create this method here. So we have our parse method here, which we now just say cause compilation unit. And then we say we return a compilation unit syntax. And that's quite clean. Now, of course, things will no longer compile because our types are no longer in alignment, but we can just fix that. Was that all? Seems like it. All right, that's neat. That is neat. All right, so we changed that to root.expression. We added the compilation unit syntax. We made the constructor, no, we changed this one to pass compilation unit as opposed to return syntax tree. We added compilation unit node, yep. Made the constructor private. Removed the root, replaced it with this rule, removed the enter file token, that makes sense. Enter file token no longer needed. And we changed this, okay. Add compilation unit. You didn't miss anything realistically. I just changed the colors of the REPL, and now I just added the compilation unit. So it's all fine. All right, now let's talk about scoping for variables. So let's just look into how this works today. So if we go into our binder, what we do here is we say, well, so first of all, how do we store variables? So right now we say, so somebody in the evaluator has to hold on to a dictionary, right, that maps variable symbols to objects, right? But that's more like the evaluation state of the program. It's kind of weird that we hold this on into the binder, because the binder should not even care about the values. It just cares about the variables themselves. Secondly, what we do here is when we say bind assignment expression, we say, well, do we already have a slot for this guy? If so, remove it and then replace it with the new one. So if we redeclare variables, like if we reassign with different types, we get same behavior. Yeah, none of this is actually what we want. What we really want is we want the concept here, instead of having this dictionary that holds onto the values, we really just want to have a thing that holds onto the symbols themselves. So let's just add a new concept for this, and we call this bound scope, let's say. And the idea is that this guy is just a private dictionary from string to variable symbol, right? Because we really want to look up names fast. And then, yeah, so what do we take? So the constructor for this guy takes the bound scope parent, right? Because scopes can be nested. Then we have a bool try lookup, which takes a string name and has an out variable symbol variable, right? And then in order to get anything in, we have the same thing here. We have a try declare. Where the idea is we pass in a variable, and then if the name already is in existence, then we just say no, you can't do that, and then we just report an error. I think the other thing we probably want is we want an immutable array of variable symbol get variables. I should say get declared variables. And we probably want to expose our parent as well. So how does try declare work? Well, try declare only declares new things. So we want to support nesting of scopes, and we want to generally support shadowing. So the idea is if you have, var x equals 10, and then you say, you have a nested scope, then you should be able to say var x equals false, let's say, right? This is normally called shadowing. So nested scopes can basically replace things from the outer scopes. But if I try to do this here in the same scope, then it should be an error. So basically what we do is we just say, well, if variables contains key for variable.name, then we say return false. Otherwise, we say variables add variable.name.variable. All right? And then we say return true. So lookup, well, clearly we say if variables try get value for name out variable, then we say return true. Otherwise, we say, return if parent is null, then we can say return false. Otherwise, we say return parent try lookup for name out variable. right? Otherwise, we basically say, so first we look it up in ourselves. If we succeed, we return true. If we don't have a parent, we know it doesn't exist. Otherwise, we ask our parent. And then this one is just return variables keys to immutable array. Values to immutable array. Yeah. All right, so this is our bound scope. So instead of taking this guy now, we should take a bound scope parent. And then we say private bound scope. This is one of those bugs that annoy me because I have to save the file first. Bound scope scope. And this one is not read-only because we will modify this as we are creating nested scopes. And then we just say, okay, our initial scope is a bound scope, and it gets that parent. So another thing we want to do here is instead of creating the binder directly in the call side, what I really want to do is I want to say there's a static method, public static. Yeah, the question is, what does it return? So one thing we want to make sure is we want to return something to the caller that is more than just a bound expression, right? Because as I said, when you bind a program, one thing you want to return to the caller is, well, what functions did you declare or what variables did you declare? So our thing right now is a bit on the simple side because we don't have functions yet. So, but we still can introduce the concept and say there's a bound global scope, I think is what I called it. And the global scope basically has a few things, and it basically catches the root of the program, if you will, not the members of the not the bodies of any methods yet. And so what this thing would contain is basically, well, it might have a previous one. So this is the REPL experience where you have, a previous submission. Yeah, you have an immutable array of diagnostics, which are basically the result of binding the global scope. You have the immutable array of variables that you declared in the global scope. And then in our case, we also have the expression, which eventually we will no longer have. But for the time being, that is good enough. And now we can say initialize these guys. And now this is actually, what's your problem here? Property bound expression is less visible. Oh, yeah. Let's make this guy internal. All right, so now we have this one. And now instead of doing this, we will say, well, let's make our life somewhat easier and have a static method bound global scope, bind global scope, let's say. And what do we take in? Well, we take in a compilation unit syntax, right? And now what we will do is we will say var binder equals new binder. In our case, we don't have a parent scope yet. We handle this later. And then we say binder bind expression for syntax dot expression, right? And now we say var variables is binder scope get declared variables. We can say diagnostics equals binder diagnostics to immutable array. And then we can say return new bound global scope. Our case is null right now, diagnostics variables and the expression. Oops, expression. Right, and now instead of doing this here, we are saying bind global scope for our syntax tree root, and then we say this is global scope. Now we say global scope diagnostics. And this should pretty much be it. All right, now if we say 12 times 12, great. If we say a equals 10, we crash. Greg is saying get declared variables is missing in E. Let's fix that because typos annoy me too. Get declared variables. Oh yeah. We did a bunch of work here, but we don't actually use our scope. So let's actually delete this guy. Haha, now things start to become red. So instead of variables keys first or default, we're now saying scope try lookup for the name. So we say if not try variable then we return undefined name. Right, so we don't have declarations yet, so in our case we will basically say if not scope, actually we say, so we need the new variable here, and then we just say scope try declare variable, then we report an error. And we say diagnostics report variable already declared. What do we return? We say probably we want that we return on the syntax identifier span, and we probably want to return the name, so include the name as well. So public void, and we say variable is already declared. All right, let's try this. So 12 times 12 works, a equals 10 works, and now we get an error because now we have scoping, right? So now every submission is effectively individually bound, and so the second expression here does not have access to the previous one, so things don't work yet. So let's fix that. So the way we would do this is we go back to our compilation here, and so instead of doing this thing every single time, let's do another one here. So in this case it's actually internal bound global scope, and we actually need a variable here, private bound scope, bound global scope, global scope. And we're now saying if this guy is not set yet. If Brown's global code is null, then logically what we do is we say global scope is this. Return global scope. Gee, typing is not my it's not my strong suit. And then instead of this, we're saying this is the global scope. So this doesn't change much in and of itself, but like this allows us to do lazy initialization of our global scope. The one thing we want to make sure is that everything here should be, we do everything immutable, so we actually have some thread safety. So this is not a good idea for thread safety, because if now multiple threads access, let's say, evaluate, they all get different instances of global scope. So one thing that you can do is you can say var global scope, and then you say interlocked compare exchange, which basically says set this guy here, and then set it to global scope, but only when the value is still null. So logically what that means is that whoever is first gets to set it. And so for all eternity now, if people observe global scope, everybody sees the same result. And then yes, other people might initialize, like create another global scope, but it gets dropped on the floor. It's a very common pattern to make sure things are sound. So now we have this. Now what we really want is we want to have another method here, which allows us to chain multiple submissions together. And so what we say is we say continue with syntax tree, let's say. No, not token, tree. That would be odd. And then let's have a private constructor that takes a compilation previous and then this guy just forwards to that constructor. So we say syntax tree. Oh, sorry, we say null about syntax tree. Why do I do this? I don't know. I think it's reached somewhat nicer if people don't just pass in values there. But strictly speaking, it's not required. Syntax, no, compilation, syntax tree, no, this syntax tree, right? All right, so what has changed? Well, so far nothing has changed, but one thing we want to do here is we want to pass in the bound global scope previous. And so when we now return the global scope, we will include the previous submission here. And so when we do this, we say, well, previous dot global scope. Previous might be null, so let's do conditional null here. And so this way, the programs get chained together, if you will. So what does it mean now for our global scope here? So this one accepts a scope. So let's give him a scope. So let's have a private static bound global scope, no, bound scope, get parent, or I should say create parent scopes. And we take in a bound global scope previous. So let's create a stack here because we need to walk the stack the opposite order, if you will. So we first have to remember effectively all the previous ones. So this would be bound global scope. Actually, is that true? So as long as we still have a previous, we say previous will be previous dot previous, and then we say stack dot push previous. So if we now have submission, so logically what we have is we have, you know, submission 1 points to, sorry, submission 3 will point to submission 2, which will then point to submission 1, right? So this is basically the chain of previous submissions on the command line, right, or in the REPL experience. And so now what I do is I put them on a stack so that I get them in the opposite order. So I get submission 1, submission 2, submission 3, because I need to create the scopes in the opposite order, right? And now we can say while stack count is larger than 0. So of course we need a bound scope current, and we start with null. Then I say var scope is new bound scope, passing the current one as the parent. And then we say scope, yeah, now we say for each var variable in our scope, not scope, in our, sorry, I run out of names. It's not great. What is it? It's stack dot pop. Here we go. And then we say global dot variables. We say scope try declare, because we don't really care in this case because we now will succeed once we check the return type. And then we say current is the scope we just created, and then we say return current. So maybe we should call this parent, and then we say this is how about we just say this is, I just use previous here because I think it makes it a little bit easier to understand what's going on. Right, and then we say var parent scope is get parent, create parent scopes for previous, and then we pass this in as the parent. So the idea is effectively that all previous submissions are outer scopes logically to our scope. Now, of course, now we have to go in here in our root program and actually build that chain. So we need a compilation. It's called this previous. No, sorry, compilation previous, which starts at null. And then here we're saying, okay, this is where the constructor would have been probably easier. So if previous is null, then we do this, and we create a new compilation. Otherwise, we say previous continue with this one. Otherwise, we chain it. Then when we say when there's any diagnostics, if there's not any diagnostics, that's when we remember this. And then we say this is compilation. The reason being, if things are not successful, you don't want to chain them together. Otherwise, every single time now, you will get the same errors over and over again, which you don't want usually. So let's check out whether what I said is true. So if I say a equals 10, a, and now I can refer to a again because it's in the parent scope of ourselves. But I can also redeclare it because it's a nested scope. And now if I refer to a from this moment on, well, then it's actually false. So then it's actually Boolean. So now we have the proper semantics that we want from a REPL, where we can replace things. All right. I hope this worked out. Does that make sense to everybody? All right, so then the only thing I think that is right now a bit weird if we go to our compilation here, I think what we want I think we want to chain the diagnostics too. Let me think about this for a second. I don't think I've actually thought about that. So let's cheat for a second. So let's say instead of doing this only in the successful case, let's do this all the time. Because what you would now expect is if you say A equals B, if I say A, A equals B, A. Yeah, now we crash in the evaluator. So what you really would expect to happen is we should get the same error again because we chain the compilation. So if the previous compilation has errors, the subsequent one has to have the same error. So one way to do that let's go to our binder. I think the easiest way to probably fix that is to say yeah. How about we do this? We say if previous is not null, then we say diagnostics equals diagnostics insert range 0 previous diagnostics. Feels a bit heavy-handed, but probably does the job. So if we now say A equals B and I say A, still crash? Why do we crash? A equals B, A. Yeah, that makes sense. Oh, of course we crash now because we, yeah, we don't support, we don't look up the right text. So when we try to print the error message, we always go through the current text, which is not right. So instead of doing that, which would be well, I guess our diagnostics don't have enough information yet, do they? They only have to span the message. So this is one error that we can probably ignore for now, because eventually we will remember in the diagnostic not just the span, but also the document where it came from, and then this will work fine. But for now, given that we don't want to do what I just did anyway, we only remember the successful ones. This is not going to be a problem. So we say A equals B, and I will say A again, like I get not the same error, but I get a different error, but that's fine. That is kind of what we want. All right, so I think this is what I wanted to do here. Okay, okay, so we have done this one. Oh yeah, there's a few more things. So one thing is, we have our meta commands here. So one meta command we should add is reset. And reset is effectively just dropping the previous compilation on the floor so that you start with a fresh compilation with no variables. Small thing, but can be useful. So if I do this now, so if I say, a equals 10, and I can now refer to a until I do reset, in which case there is no a anymore because there's no previous compilation. Yes, so the other thing we should do, now that we have proper rules in our binder for looking things up, actually, can we? Let me think about this for a second. Yeah, I guess, what happens if I do this, right? A equals 10 times a equals 20. We get an error because right now, every single time we have an assignment, we are declaring a variable, which is strictly speaking not what we probably should do anyway. We should only do it on, if it's not already declared. But then also when we say this, it will, well, we get the same error, which makes sense. So we should probably do something. Yeah, we do this later when we actually have the variable declarations, I think. Right now, it makes no sense to do that. Yeah, I don't know what I was thinking doing this here. All right, so this one should fix, though, the other bugs that Dimitri filed. So let's quickly verify that that is actually true. So he said a equals 1 plus b. Yeah, you get that error. And now we say b equals a plus 1. You just get variable a does not exist. Okay, that fixes that one for sure. And then this one is a equals 10 plus a equals 1. Yeah, right now you get variable a is already declared. And then if I say a equals a plus 20, you get variable a doesn't exist. Yeah, thinking about it, I think we probably still want to fix the binder here to say, so assignment expression. We say if scope try lookup name. So if that fails, out var variable, then we declare the variable. In which case this error cannot occur. Yes, and now when we have a variable, now let's check the type. Now we say variable type. If the variable type is not the same as, or I should say, if the bound expression type is not the same as our variable type, then we say diagnostics report variable or cannot convert. And so in this case we say this is the syntax, what is it, expression span, and we say from type bound expression type to variable type. So eventually we'll have conversions, but right now we do not have conversions. And now we say return bound expression here. So let's do this instead. I think that makes more sense. So we don't have this one here, but we do have this one here. Cannot convert type from type to type. Cannot convert type from type to type. Something like that. So if I now say a equals 10 times a equals 20, what? Interesting, I must have parity issues here. Okay, that works. And now we get an error because the second time we try to, so we looked up a in the scope, it already exists in the same scope, but now it has the wrong type. So now we fail with cannot convert the types. So this means now that if I go back here, we should get the correct behavior here as well. A equals 10 plus a equals 1. This is 11. And if I now say a equals a plus 20, we get the correct behavior there as well. And then this one I think should already work. 1 plus b, b equals a plus 1. Yeah. A equals 1 plus b, and then we say b equals a plus 1. Yeah, you just get that these guys don't know each other yet. All right, so this makes sense. So I think I'm happy with that. So we have the previous compilation, we have the reset, we initialize it, remember it. Then we, instead of using our dictionary here, we actually use proper scoping and scoping lookups. We have a bound global scope, we have our bound scope. Yep, we use all of that stuff here. We have this error here, so git commit dash v. All right, so allow compilations to be chained. The chaining allows subsequent submissions in the REPL to get access to previously declared variables. This also introduces scoping so that we can look up variables and type check them properly. Fixes number 14 and fixes number 15. Interesting. How did that fail to build? No, that's not what I wanted. What I wanted was to see where the build is failing. We have failing tests. How is that possible? Interesting. Oh, I see. Well, yes. So when we earlier introduced our compilation unit, we did not update our tests. So when we parse this guy here, we get back a compilation unit syntax. So we have to say expression here. And the same here as well. In fact, let me extract the method, which now went God knows where, because we will need this eventually. And we call this parse expression. So this is, so let's actually introduce some locals here so we actually see what the heck is going on. So this is the syntax tree. And then this is the root. And so instead of doing this, we say parse expression. And then we do this. That should fix my test breaks. Okay, now our tests are passing again. So let me do this. Let me add these guys here. Fix test break. So in this case, I'm actually kind of in the mode to clean this up. So let's just merge this commit with this one here so we have it clean. So now let's see where we are. So let's just remember that that one, and now let's just push this one. Some handy git foo here. So basically what I now have is I've basically re-pushed this one here, which now actually includes our fix for the test failure. So you look into this change here. It also includes our parse expression changes in the tests. And then that's the end of that. And so ideally now when this guy runs, it will just pass, which I cannot do by clicking on the dot, which is, well, you can actually, never mind. So while this is happening, let me now merge, so let me clean my working copy. And now I can just merge in the SHA-1 with or chaining again. So now when we look at the history, here's our compilations to be changed. Here's our chaining again. So after this one is done, so test succeeded. Which means this one should be green any second now. What is happening? Well, I guess it's not. No, it is. All right, so now here's our new one, building again. And I guess when I run locally, I should not have any test failures either. All right, so this is working fine. Now let's actually do the next stage. So now we did a bunch of work and we finally do what I'm promising we will do. We will add statements to this whole thing. And so logically what we want here is let's just start at the syntax level, because that's probably the easier one. So let's first think about what this will look like. So we have right now everything at the compilation unit syntax level is an expression. So the first thing we would need is we need a public abstract class statement syntax, which extends syntax node. Then we will have a public sealed class, let's call this block statement syntax. And this one is what you would normally think of. It's basically just the ability to have syntax token, open brace token, takes an immutable array of statement syntax statements, and then it has a syntax token close brace token. And then we say this is syntax kind block statement. Let's create a new category here, statements, and put this guy here. But okay, so now we can compose multiple statements, assuming we put them in braces, but then we don't have an actual statement yet. So we need an actual statement, and one of the most popular ones in C is obviously the expression statement, which you can think of as basically just a wrapper around an expression, so you can make expressions statements. And you can decide now also what expressions you consider valid, right? So for example, you could say that A equals 10 is a valid expression as a statement, while A plus 1 you can decide is not, because this one has no purpose, right? Nothing, there's no side effect, if you will, right? So usually the rules for C-based languages are assignments are valid statements, things like this, which we don't have, increments are valid statements, and usually just method calls are also considered valid statements. So in our case, because we have a REPL, in a REPL environment, you generally want to consider everything a valid statement because that simplifies your life a little bit. So we just say this takes an expression syntax, expression. And then in C, you would probably also take a syntax token for the semicolon, right? But our language doesn't have semicolons because we're civilized people, and we don't need semicolons. All right, so let's say this is syntax kind expression statement. And let's put this guy right here. All right, so now let's move them to separate files. And now let's first fix our lexer, as we do, to actually include the braces. So we say this is brace token. Let's put these guys somewhere close to the parentheses. Of course, we now have to change get text. Same thing here. And I think this is all I needed, right? Now let's go to the parser. And so parse compilation unit right now says, all right, let's first fix this guy here. So this guy doesn't take an expression now, it now takes a statement syntax. And of course, parser tests right now. I can fix this right now here. So right now, this guy is now this is a statement. So we can say var statement equals root statement, and now we just said assert is type expression statement syntax. And so the is type check basically checks that this statement is this statement syntax is actually of type expression statement syntax. If this fails, it will just fail the test, and then it returns the expression that this guy is holding on to. So this solves our problem in the test. So we basically just want an expression, not a statement. And now, okay, now we have to change the parser to actually do that. So let's introduce a new thing, private statement syntax, parse expression, parse statement. And we just make our life really easy. We say if the current token is syntax kind open brace token, then we say return parse block statement. Otherwise, we say return parse expression statement. Right, and the expression statement is super easy. All we say var expression, we say parse expression. Oops. And then we say return new expression statement syntax for this expression. And then we say this is block statement syntax. So we say, okay, var open brace token, match token syntax kind open brace token. We will eventually need a close brace token as well. we need a bunch of statements. So we say immutable array create builder for statement syntax, and then we just say return new block statement syntax for open brace token statements to immutable, and then close brace token. Oops. Right. And now in between here, what we're saying is we say while current kind is not syntax kind end of file, and current kind is not syntax kind close brace token, we say var statement equals parse statement, and then we can say statements add statement. Oops. So logically what I do is I say, well, after an open brace, I just expect a bunch of statements, right? And how do I know that I'm done? Well, I'm done when I'm literally out of tokens, when I'm standing on an end of file token, or if I'm not seeing a close brace token yet. And the nice thing is, like, this will definitely consume all tokens, right? So we'll never get into infinite loop here because we made sure that our parser will always consume one token, right? So if we go into parse statement, and then we say parse expression statement, and then we go here to parse expression, we say parse assignment expression. So eventually we end up going to parse binary. This does its magic here, and then eventually you go down here and you will find that actually I'm wrong. You can actually create an infinite loop here. That is a problem. That is something we probably want to think about. Parse statement. First of all, that is statement. But let's handle that secondary. So now we need to change our binder as well to actually bind these guys. Make sure that we take a note about can we run into infinite loops? So the binder now needs to obviously also bind from the expressions down. So we will do something very similar to bind expressions. So we say bind statement. We take a statement syntax, and then we return a bound statement, which doesn't exist yet, or we will make it pop into existence soon. So now we don't need those guys here. And now we say, of course, what do we have? We have block statement. So we would say bind block statement, and we take a block statement syntax. And of course we have the expression statement, in which case we bind an expression statement. And in fact, I don't think any of them should be public because of the way we wrote everything. Everything can be private, I think. All right, before we go anywhere, let's first create these types here. So we need an internal abstract class bound statement, which is a bound node, right? We need an internal sealed class bound block statement, which is of type bound statement. And this guy, well, this guy just gets an immutable array of bound statements. and we say this is bound node kind block statement. Let's create this guy here, and I guess same thing here. We say this is expressions and this is statements. So we need this guy, and then we need another one, which is our bound expression statement, which basically just takes a bound expression. And then this guy, and of course the constructor is this one, and we say this is an expression statement. All right, let's move these guys to separate files. And now if we go back to our binder, these should be pretty straightforward to implement. So we say statements, same thing here. We say we need an immutable array of bound statement. And then we just say for each var statement syntax in syntax statements, we say var statement equals bind statement for the statement syntax, and then we say statements add statement, and then we can just say return new bound statement syntax, bound block statement for our statements to immutable. Right? And then this is even easier. We can say expression is bind expression for the syntax dot expression. Return new bound expression. No, bound expression statement for this expression. All right, this is probably like either here on the parser is where we would say, well, if you're not in the script context, you would block certain expressions from appearing. And then, yeah, instead of saying this, we say bind statement here. And then, yes, our bound scope, instead of returning this guy, it would return the root statement, bound statement. Let's call this statement. Of course, this is a bound statement now. So this should fix at least most of this stuff. And now, of course, our evaluator needs the same thing here. We need a evaluate statement. And now this is obviously void, right? Statements don't have values. Bound statement. So what we will do is we will cheat a little bit, and we say we have a private object last value, and we will say evaluate statement for bound statement. So we get this guy, and then we say return last value. And then here we say, what is it, block statement. This is evaluate block statement for bound block statement. And then we say we have an expression statement. So we say evaluate expression statement for this guy. So let's create those guys. And this is pretty simple. We just say for each var statement in node statements evaluate statement for statement. And here we say last value is evaluate expression for node expression. Right? And then the idea is if we have multiple statements, we will just return whatever the last statement, whatever the last expression statement was. Jesus, today is not my day apparently. Yeah, and this is obviously node. So it actually compiles, and yes, this cannot do this. We have to say break here because we don't actually return anything. Right. Now I'm curious what will happen if I run this for the first time. So I can say a equals 10, right? Yes, I can say open brace, a equals 10, a equals 100, a times a, close brace. Wow, that worked on first try. That's pretty good. Parser CS line 67 has a missing S in expression. Let me check that. What was it? 67. Well, I might have fixed this now. B testicle, tell me a little bit more because I may have changed the line numbering at this point because I inserted more stuff. I guess it was the local variable, right, that had the spelling error because I think I fixed that already. Alrighty. So we did a bunch of stuff here. So we now have the concept of expressions and statements. And with the expression statement, we can chain one into the other. And so the root of the program is now a singular statement, which can be a block, which allows you to do arbitrary nesting too. Yeah, in fact, let's talk about the nesting for a second while I'm running the tests. So you can do this, right? You can say a equals 10. You can open up a new block. You can say a equals false. Or not, for that matter. Did we break this? Yep, I think we did. But that is because of our yeah, because we changed from try declare to try lookup, and try lookup will walk all the parent chains. So that's actually a bug. But we will fix that by introducing variable declarations anyway. So I'm not too worried about this. But basically, you have nested scopes. You can have now indefinitely nesting, if you will, of statements. Except that our statements right now are not super useful because the only statement you can ever put into things are expression statements. So, but one step at a time. Add statements. Did I break anything yet? Nope. Good. All right, now we have statements. Now the other thing we really want is the ability to actually declare variables, like civilized people, not implicitly creating them on first assignment. So let's do that. So let's go here and say, where is our statement syntax? Here. All right, so let's say public sealed class, what is that? Variable declaration statement. You know what? Variable declaration syntax. Good enough. We say this is syntax kind variable declaration, and that is a statement. So what will that look like? Well, I want this to look like this: var x equals 10, or let x equals 10. So, and then this is basically a variable you can assign again. This one is a variable that is read-only. So now let's say we have a variable declaration syntax here. So what do we need? We need a syntax token, keyword, well, let's just say keyword, and then we have a syntax token identifier. Then we have a syntax token equals, I guess equals token, and then we have an expression syntax initializer, right? Something like that. All right, now let's first select our keywords here. So we need new keywords, so that will be in our syntax facts class. There's a few new keywords that we need. We need let, that will be the let keyword, and we need the var keyword. And let's just sort them because, well, why not? So I guess L comes before T. So that when we add keywords, we just add them in some sensible state. So like this, I guess. And we have to add them here as well, unfortunately. So we would have to say this is, the let keyword would be let, and the var keyword would be var. Right? That seems right. All right, now that we have that, we should be able to do that here. And so now we would say, well, else if current kind equals syntax kinds let keyword, or current kind equals syntax kinds var keyword, then we say return parse variable declaration. Right, so let's create this guy. And then just for easier reading, let's just make this a switch. All right, so we say keyword, let's say expected. So current kind equals syntax kind let keyword. In that case, it's this one, or we say var keyword, right? And then we say var keyword is match token expected. And then we say identifier equals match token syntax kind identifier token. And then we say equals is match token syntax kind equals token. And then we say var initializer equals parse expression. Let me say return new variable declaration syntax for keyword identifier equals initializer. That sounds about right. Now let's fix our binder to include this guy. So we have a new thing here. It's our variable declaration. We say bind variable declaration syntax. We need the method. Yep, and then same thing here. So we need an actual type for this. So we say internal sealed class bound variable declaration would be bound statement. Well, what do we take? I would say we take a variable and we take a bound expression initializer. That seems about right. So we say bound node kind variable declaration. How about that though? And let's put this here. Let's actually do the same in the syntax kind enum as well, because we have put the variable before the expression all the time, because it seems somewhat logical. All right, so now we declare a variable. This is where we say var variable equals, well, first of all, we bind the expression. Bind expression for syntax expression. Initializer, I guess. So var name equals syntax identifier text. Var is read only. That is when the syntax keyword kind equals syntax kind let keyword. And then we say this is a new variable symbol for the name, for is read only, and for initializer dot type. So now let's remember that the variable, well, that was read only, bool is read only. Now we can say if scope try declare variable. Now we can fail properly and say report diagnostics. What do we say? Report variable already declared. We would say syntax identifier span for name, I think. And then we say return new bound variable declaration for variable and our initializer. Right? That seems somewhat sane. Now what we will do is we will also now change our assignment expression to no longer do this one here. Instead we say same as here, although we can probably just return the bound expression here, at least it has the same type. Yep. The other thing we need to check now is if variable is read-only, then we say diagnostics report cannot assign for actually, let's be creative here and let's say let's report it on the equal sign. Why not? Why not? I mean, we have all the information, might as well just use it. Variable is read-only and cannot be assigned to. Right? So let's see what happens. Actually, let's not see what happens because I know it will not work because we haven't updated our evaluator yet. So let's go into our evaluator. Add this one variable, variable declaration. We say bound variable declaration, evaluate variable declaration. And we say var value equals evaluate expression node initializer. And then we say the variables for node variable equals value. And we say probably last value equals value. Why not? And then evaluate variable expression, we just access it. And assignment, we just put it there. Seems reasonable. All right, let's see what happens. All right, so let's do var x equals 10. It's 10. Var y equals 10. That works as well. Var x equals false also works. But if I say var x equals 10, and I can say var y equals x times 2, I can say var z equals x times y. I should be able to say var z equals 100, but I should not be able to say var x equals false. Variable z is already declared. Variable x is already declared. Interesting. Oh, I'm an idiot. I am an idiot. I am an idiot. So one essential thing that we have not done in our binder to build all this elaborate functionality to track our scopes. And then the one job we had was to say scope equals new bound scope for the current one. Current one is not the parent. And then after we do this, we say scope equals scope parent. That's the part we didn't do. Right? Because every single time you add the nesting, you need to add another scope. So let's try this again now. So we say var x equals 10. We say var x equals false should be possible. Var z equals x should be possible. Oh my god. Yeah, I added a semicolon. Not good. Var x equals 10. Then we have another scope. We say var x equals false, var z equals 10, right? And now if I say var z equals true, that should work, right? Proper scoping. Now, what should not work though is to say var x equals 10 followed by var x equals false, because they're not in the same scope, and that will fail. Sweet. Now let's actually try the other one. Let x equals 10. And now let's say x is 20. Variable x is read-only and cannot be assigned to. Sweet. That is nice. Yeah, I think that's pretty much var x equals 10. X equals 20. That works. Y equals 100. Doesn't work because we don't create variables out of thin air anymore. That is nice. Okay, let me fix this blunder here. Fix scoping for block statements. And then we have this one here where we add variable declarations, variable declaration. We do this, we do that. Yep, that one, that one. Variable already declared, cannot assign. Variable declaration, evaluation. Yeah, that's fine. Add the keywords. Track that guy. All right, git commit, add variable declaration statements. Git rebase master -i. Just for prosperity. Yeah, we can just merge this with the previous one because that's where we introduced the statements, that's where we introduced the block statements, so that's where it logically belongs. Great. Run this. And let's see where we are. Sweet. Now I think this is the last one where we have to update our tests, because our evaluation tests right now assume they can do that. We can now just say var var a equals 0, and then we can say a equals 10 times a. That should work. Yes. All right. Let's push this over. All right, so I think we have pretty much covered everything that I wanted. I also wanted to cover testing, but we're out of time now, and as it always is with projects, testing is always the last thing you do. Anyway, so there is an interesting thing that we need to do moving forward. Is like we need to do more work on testing in particular. I want to be able to express more declaratively what my expected errors are, and then also somehow express where they occur in the input, so I don't have to mess with the spans by hand. We will also have to test more of our edge cases, like for example, when we declare variables that we cannot redeclare them, that scoping works properly, that when we assign to them, that and they're declared read-only, that this works. And I will do this in the next episode. The other thing I need to look into is the, as I said, there is probably a bug. We can probably check this really quick. Run src mc.csproj. Yeah, not like this. I think we might actually have a bug in our parser where if I start with this, well, there's that too, but I was expecting that to be an infinite loop actually. What would be a non-operator? What about this? Maybe we don't have the infinite loop problem. I was concerned that when we, because of the way our parser inserts token, that if we not started a valid statement or expression, then we will go all the way, down to the expression statement, basically fabricate tokens out of thin air, and then in our block statement, actually, no, it's in our block statement, right? That's exactly right. Yeah, so we have an infinite loop problem here. So when we go into our block statement loop, right now we say, well, we parse statements until we find an end of file token or until we see a close brace token, right? But now the problem is the next token never starts a statement. So what we will have to do in the next episode is find a way to break those loops and not end up in this infinite loop problem here. So let me just add this to my notes, and I think we will have some fun fixing this. All right, I think this is all that I had for today. I hope you found this entertaining and funny. I'm sorry that the YouTube streaming didn't work today. I will upload the video later, and then hopefully I see you guys next week. Bye bye.